big blockchains at the moment are really limited in their scalability because they've pushed this security decentralization kind of philosophy. So the question is, what can we do? Are we doomed? Is there no such thing as a layer one anymore? Do we just go back to Web 2?
Essentially, the idea is then you have layer twos, which are designed to help scale layer one blockchains. What are layer two scaling solutions? Well, they are just things built on top or third-party systems on top of the base blockchain, designed to enhance efficiency, scalability of the underlying blockchain. And the crucial thing is they're designed generally to take computation or data or both off-chain.
So welcome to another episode of the Untangling Web3 podcast. Today, we're going to be talking about a very interesting topic. We're going to be talking about the layers in blockchain technology. So these are kind of banded around a lot. We have the terms, layer 0, layer 1, and layer 2, and they refer to different layers of the blockchain infrastructure. And they each serve a distinct purpose in the blockchain ecosystem. And understanding these layers is actually extremely crucial for grasping how complex blockchain networks can actually operate and how they can be scaled and optimized. And yeah, that's the topic that Jack and I are going to be exploring in today's episode. But before we get there, Jack, how are you doing today, my friend?
Yeah, all good. Thanks, Alec. Feeling pretty good. Excited to cover this topic, actually. This is a very important one, and it's a bit of terminology that you really have to get right, I think, to talk about all sorts of other topics, right? And we're going to be talking about zero knowledge systems in future episodes. So this is definitely an important one. So maybe just to start things off, we've mentioned already layer 0, layer 1, layer 2. I've also heard the term layer 3 coming in recently, but we're not going to cover that in today's episode, maybe in a future one. But just to set the scene, so we've done episodes already on blockchain. We covered blockchain in detail. We all understand what that is. For the purposes of today's episode, consider blockchain as layer 1, right? That's what we're thinking of as layer 1. So layer 1 is then sandwiched between something below it, layer 0, and then something above it, layer 2. And essentially, the idea is layer 0s are basically infrastructure to enable and build layer 1s, blockchains on top of. And then you have layer 2s, which are designed to help scale layer 1s, layer 1 blockchains. Okay, so that's at a high level kind of what we were kind of hoping to go through today, right?
Boom. Done. Episode over. We've solved it. No, just kidding.
That was easy.
So that's the high level intro. And now should we just jump into it? I guess it makes sense to start at the beginning, which really is layer naught, but it's a bit more fluid than that, right? I guess. So layer naught is, as Jack said, the network infrastructure layer. And this is really foundational. And it's quite a broad concept, I guess. Like it's kind of this, I guess, includes all of the hardware, the networking technologies that underpin, not just blockchain technology, but underpin messaging, internet, all these kind of things. When we talk about, TCP, IP, the actual communication protocols, this is really what we're talking about. And they underpin absolutely almost everything we do in blockchain technology. So that is layer 0.
Yeah. And I think basically now we're talking about what's known as an abstraction layer model. And you have an abstraction layer model for the internet itself, right? Forget Web3 for just a moment. So we have in Web 2, we have what's known as a TCP IP model, transmission control protocol, and internet protocol model. And that splits up how we understand the internet into a series of layers. So everything from the network layer, the base layer, as you said, how messages get communicated, up to the application layer, which is kind of what you see when you're online and when you see on a website or on an application or something. And when we're talking about layer 0, layer 1, layer 2 in the blockchain Web3 world, this is kind of a separate abstraction model that we're talking about here. In practice, most blockchains and L0, L1, L2 all actually operate on top of the TCP/IP abstraction model. So just before we get out the gate, it's important to understand that we're talking about something separate. But when we're referring to layer 0 in the Web3 context, it's similar or analogous to the network layer in TCP/IP, right? That base layer that you can build all the blockchains on.
Okay, that makes sense. And I guess the reasoning here is that when we think of, like, say, blockchain technology that's kind of underpins most of what we do in Web3, we talk about like distributed networks, right? And that kind of assumes a degree of messaging between nodes that spread across, say, different regions, different areas, different actors. And we don't actually have to say that it's completely necessary to use the internet to do that, to achieve that, right? We use the internet to communicate, say, what the state of play is, transactions between two parties with the network, for example, because that's the most efficient way to do it right now. But we could, in theory, use mobile connections. We could use, I don't know, RFID tags, Bluetooth, all this kind of stuff. We just kind of refer to the internet, TCP, IP, because that's the most efficient way, as we all know, to kind of transact and transmission around the world.
Yeah, and it's obviously battle tested. We use it in everything else in Web 2, so it makes sense that most of it is built on top of TCP/IP. But kind of crucially, with layer 0 in a blockchain context, so think about what you actually need, right? Why do we need networking? Well, as we say, Bitcoin as an example, you have the software to run. So if you're going to be validating and building transactions and blocks and things like that, you have the software, but then you also have this network of other nodes you need to communicate with, right? You need to send transactions and blocks to other people. Even if you're not running the software yourself, you might need to send it in from your wallet, for example. So there is a notion of networking or network connectivity that you need from all the different actors. And layer 0 is referring to everything at that kind of layer. Now, there's also, just to muddy the waters a little bit more, there's also what people call layer 0 blockchains. Okay. So you don't need a layer 0 blockchain for a layer 1 blockchain to work. And this gets complex very quickly. I think we'll talk about L0 blockchains in a separate episode because they're the whole thing unto themselves. But the thing they're focused on is not necessarily just letting blockchains exist. L0 blockchains are these kind of special general purpose chains or networks designed to let other L1 blockchains communicate. So maybe your Ethereum and your Solana to communicate with one another. And there's a few examples of that, like Polkadot, Cosmos, you'll have seen, which we'll definitely go into in a future episode. But it's just crucial to know that they're all about this kind of interoperability idea in Web3.
Okay, that makes sense. But for now, we're going to try and keep it simple and say that this is just, the underlying infrastructure that enables us to build blockchain technology on top of right now, right?
Exactly. Yeah.
Okay, so that's layer 0s, the hardware, the infrastructure, the protocols that enable basically the network to propagate transactions to really support the things that are going on top, which is the layer 1. Now, this is the bread and butter of the podcast. Hopefully, you listened to our second episode, I think, which is on blockchain technology, where we really go into some of the details of what a blockchain is. But just to recap some of that, the layer 1, like we said, is the blockchain architecture. This includes, the blockchain protocol itself. If we're talking about Bitcoin, it can be, the consensus mechanisms, how blocks and transactions are propagated. We can have Ethereum as an alternative layer 1, for example, or other standalone blockchain technologies. And quite crucially, I think typically when we talk about blockchains, it's a decentralized ledger, and they just record transactions across many computers. And we've talked about it a few times now. We refer to this as like the piping of Web3, but I guess that gets a bit confusing because maybe the layer 0 is really the piping, and this is like what the infrastructure is built on top of the piping, maybe the toilets, whatever that is.
Yeah, that's what I mean. It's very abstract when you go down to the L0 stuff that we were just talking about. But I think it's much easier to visualize and understand what we mean with L1. As we said, the network of Bitcoin nodes, for example, or Ethereum validators who are maintaining the blockchain directly, who are adding transactions, propagating transactions to other people and things like that. So this is, as you said, this is the bread and butter. This is what we think of in our mind's eye when we talk about blockchain and a lot of Web3. This is what underpins everything on top of it, right? That's kind of idea with the layering, is that each lower layer underpins the next layer. And for most intents and purposes, all you'd ever need to worry about is, okay, what blockchain am I using? And then what applications on top of that are using that layer 1 blockchain. But yeah, so as you said, blockchain, we know the characteristics broadly. It's a distributed ledger for recording transactions immutably and doing payments and things like that. Also doing smart contracts in some cases with various blockchain platforms. It's the facilitator for all of the fun stuff we can do at Web3.
Yeah. And, when we're kind of talking about the layer 0 stuff, there's very few important kind of protocols that we're talking about, very standardized, very used across the board. That's why the internet's so successful. When we talk about blockchains, the layer 1 stuff, well, there's thousands of blockchains, right? There's maybe 30 or 40 that are incredibly popular, each of them being slightly different, which, the lack of standardization there actually probably doesn't help the ecosystem generally. And we've kind of said in previous episodes, we expect there'll be maybe a few that kind of end up being the victors and everyone uses them as their layer 1s to build everything on top of. But yeah, Jack highlighted some of the key characteristics there, which are the consensus mechanism, maybe the native token they use, the security model, all this kind of stuff. But importantly, to lead us on to, layer 2s and the need for having layer 2s, there's kind of 3 characteristics that we really want to focus on for layer 1s. We'll go through them right now. So the first one is scalability. So this is effectively the blockchain's capacity to handle a large number of transactions. I think Jack and I have spoken about this in detail, is that, a lot of kind of the major blockchains right now, Bitcoin, Ethereum, they don't have much scalability. That's the kind of the conception, is that most people don't think they have the kind of the level of scalability to support, the internet of value. If a blockchain was to really be the internet of value right now, which is the piping of Web3 to handle all the data that is transmitted theoretically, that would need to handle around 5 exabytes daily, which is 1 billion gigabytes daily. And obviously that is not feasible on, say, Bitcoin, for example. If Bitcoin alone was to just be the digital cash system of the world right now, it would need to do billions of transactions every day. So scalability is the first kind of characteristic we want to talk about when we consider these layer ones. And as you can probably tell already, it's not actually suitable or fit for purpose in the current implementation.
Yeah, it's one of the hottest topics, isn't it, in Web3 scalability? And 5 exabytes per day, half of that's probably just your search history, Alec, and God knows how
All
much. How much?
ChatGPT.
Don't give it all away. Don't give it all away. But no, so yeah, scalability is hugely important. The second piece of the puzzle, or the big characteristic that people talk about with the L1s, is obviously security. And it's one of the big value propositions of something like Bitcoin or Ethereum, is that they're deemed a very secure way of transacting, right? And holding funds, building applications, because they're public networks. They're in the public. They can be attacked and are probably being attacked constantly. Typically, the bigger ones like Bitcoin and Ethereum don't have many vulnerabilities, or they haven't shown themselves to be vulnerable, right? So the mechanism by which they are secured is different in different cases. So obviously in Bitcoin, we have the proof of work model alongside the kind of the fact that everything is public and you can see what's going on transparently, so that only very dedicated individuals, these miners, contribute really to the security of the system. But you have them investing a lot of money, a lot of power, resources, electricity, for example, in securing the network. So you have a lot of backing. Basically, a lot of people say it's backed by energy, which I think is a kind of fun oversimplification. And then in Ethereum, you have a similar thing now with proof of stake, where it's secured by basically people who've got a lot of tokens, who've invested a lot of their capital in owning the tokens and becoming validators in the network. So again, we understand quite well, I think, now how blockchains are secured, but that is still one of the main things that people are interested in, because that's fundamentally why they're meant to be good digital cash systems or good DeFi platforms, because we know they're secure in practice.
And it'd be interesting to see what actually happens, because we talked in depth around like proof of work being very well battle tested, right? But proof of work is no longer the most popular kind of consensus algorithm, right? A lot of chains are moving to proof of stake, as we've talked about proof of authority. There's lots of alternatives as well, which are maybe less battle tested. So it'd be really interesting to see how this kind of security characteristic plays out in all the modern chains that are kind of being designed to, I don't know, maybe compensate for some of the weaknesses that people kind of assume for proof of work, which is typically energy and scalability, right? But the last one, the last characteristic of the three that I want to come to, is this term decentralization, this taboo term that me and Jack sometimes use. Or maybe we should say distribution is probably the better term, but they're kind of one and the same, how we're using it here. And this principle is around the kind of the control and operation of the blockchain being amongst distributed actors, right? And we've kind of talked about, this is one of the crucial points of a blockchain technology, is that we're actually distributing the data, and the people that can actually validate the data and contribute to the data in a blockchain to multiple parties. And this removes the idea of a single point of failure. Really should help with, say, if there's a bad actor, there's ways to catch them out and ensure that good actors can actually contribute positively to the overall system. And we've kind of talked, I think we've talked in detail about, what is distributed. Is 1,000 nodes enough, or is 3 nodes enough? And this is a really interesting topic, but it's the third characteristic that's quite important for the conversation that we're having in this episode today.
You can go back and watch our decentralization episode where we go into this topic in detail, because it is an interesting one. Again, there's lots of different opinions on how decentralized different networks are. Bitcoin is effectively controlled more than 90% by like 5 or 6 different mining pools, mining entities. So it's an interesting characteristic, but as you said, it's about the single point of failure ultimately. And that's one of the kind of beautiful things about the design of blockchains, is they're meant to be resilient to ever having a central point of failure. They shouldn't arise. You shouldn't get one in a blockchain. So yeah, that's the 3 main characteristics, right? Scalability, security, decentralization. Now, where layer 2 comes in is, what's the problem with layer 1 blockchains? Well, it's to do with this triad, or they call it a trilemma, right? How do you get all three of these properties at once? It's something in computer science about threes. They love to put three things together and say you can't have them all at the same time, right? But the reason we have layer twos now is because people have decided, and I think Vitalik Buterin was the one who kind of popularized this idea, that you can't solve the scalability trilemma using just a layer one blockchain. You can't have scalability, decentralization, and security at the same time.
And I think that's the interesting thing, right? Is this has kind of come about because the scalability wasn't really an issue because no one was really using blockchains at scale until maybe the last 5 years or something like this. So they kind
Until
of existed
CryptoKitties took off.
until Jack was the primary user of CryptoKitties and it took off and blew up Ethereum. But yeah, like so these blockchains were existing kind of in isolation in like labs basically for academic brainchilds, right? But now they've kind of hit the mainstream and people are actually trying to gain utility and use them for the scalability problems we were talking about earlier, like billions of transactions a day to hit some of the digital cash thresholds that we need. Then yeah, this trilemma problem really came to light, and like you say, Vitalik popularized that. And it's really interesting. They do play off each other, right? So let's like talk about how they actually are, how they have this problem of threes, right? So if we want to scale, like we want to actually get, say, Ethereum or Bitcoin to process millions of transactions a day, theoretically, then what happens? So the first one we're going to talk about is the scaling at the cost of decentralization. So when a network increases its scalability, it tries to actually process more transactions per second. It often leads to centralization. So, you know, larger block sizes might consolidate mining power to entities with more resources, reducing the number of nodes that are actually able to participate. And it kind of makes sense, right? Like if I have to send every transaction I process to 50 other actors, well, that's as soon as I'm processing millions of transactions, that's me having to send like 50 times that million transactions out there into the environment. But if I have to send it to one person or a couple of people, or even if I have to hold it all myself, well, it makes the whole process far more efficient. And this is one of the things that we talked about earlier about the different Bitcoin forks, right? Is that actually this is something where we have the big blockers and then the small blockers that are actually trying to have a bit of philosophical debate around this topic and whether people do need to actually process the entire blockchain history or not.
Yeah, and it makes sense when you think about, you know, why does it cause centralization? Why is it only big entities can then run high scaling blockchains? Well, think about the Web2 world we have with Twitter, Facebook. The things that have the highest throughput on the internet are run by these huge companies, by massive, massive data centers, you know, all across California and all parts of the world. They're humongous data centers that require a lot of resources, a lot of cost to maintain and actually keep up. So yeah, it makes sense that if you want to just scale a blockchain in terms of the space, the block size, then it's going to reduce the number of people who can do that. Second way you can scale is to change the time parameter, right? So if you want to maybe decrease the time between blocks so you get more transactions through per minute or per hour or something like that. You know, you have 10 minutes on Bitcoin. Ethereum is actually much shorter. And you can play with that idea. But that method of scaling also then comes at the cost of security, for example, because if you have faster block times, then you might be more susceptible to different kinds of security risks, okay, because there's less time to validate transactions in between blocks. And to think of kind of an analogy for this, I like is if you've ever used a crypto exchange, then typically they'll say you need 6 confirmations, or you need to wait till there's 6 blocks built on top of your transaction before they'll actually release the funds and let you trade them. Now, you could take that down to 1 or 0, but you're increasing the risk of there being a conflicting transaction or a problem with your transaction in the network. So effectively, that would be scaling the crypto exchange, but at a risk of lower security for you as a user, basically.
The way I was thinking of this is if you want to try and get people into a club, right? And you have a bouncer at the door searching people down. Like if they spend 1 second searching people down, they're obviously going to let more people in than if they take 2 hours searching people down, right? And that's like an analogy for this. Like the higher the security concerns, the less easy it is to have high scalability. And then, yeah, obviously the counter to all of this is that decentralization and security, if you want to have a high level of decentralization, a high level of security, obviously comes at the cost of scalability. And, you know, for example, BTC Bitcoin, they prioritize security and decentralization, and they have really low and slow transaction speeds and much higher costs. For example, at BTC, I think we said on average is around 7 transactions per second. Ethereum's around 30 transactions per second. So it seems like the big blockchains at the moment are really limited in their scalability because they've pushed this security decentralization kind of philosophy. So the question is, what can we do? Are we doomed? Is there no such thing as a layer one anymore? Do we just go back to Web 2? No, that would probably be the end of the show, and not a good thing for us to talk about.
Yeah, well, I mean, then we'd be back in 2017, right, where everyone was panicking that, well, what can we do about this problem?
So what can we do? Are we doomed to stay in this Web 2 world and then just give up on all things blockchain? Well, one obvious thing we can do is actually try to revise and upgrade some of the underlying technology, right? And we've seen this play out a few times. We talked previously that BTC has several major forks that are kind of around upgrading the scalability without trying to detriment the decentralization and security too much. So they have like Bitcoin Cash, BSV, and these are different protocols. Ethereum's been upgrading its protocol to proof of stake for a long time now. But this in itself creates problems, right? If you have this kind of community that's all banding together towards Ethereum or Bitcoin, you don't want to then divide the community into different forks. Like forks can create a lot of problems. It's actually quite difficult to do. You have a lot of people relying on you, and you don't want to all of a sudden change the underlying protocol because lots of bad things can happen.
Yeah, and as you say, right, when you split the community, that also is going back to the point about sacrificing security. You then split how much of the hash power or the staking money that you have in the network. You split that across different factions, so it's not even perfect from that kind of scalability perspective. But yeah, so what else can we do? Then the other option, if we don't want to just tinker at the base layer, is to build on top of it, right? And that's exactly where layer twos come in, and also building on the side, things like side chains. But I think we'll focus on side chains again in a future episode, and we'll stick with just layer two for now. So what are layer two scaling solutions? Well, in short, they are, as we say, just things built on top or third-party systems on top of the base blockchain that are designed to enhance efficiency, scalability of the underlying blockchain. And there's lots of different approaches to doing this, and we'll kind of go through a couple of those. But the crucial thing is they're designed generally to take either data or computation or both off the layer one chain, and something that's on the layer one chain we'd say is on chain, and then it's designed to take computation or data or both off chain. That's the core thinking behind L2s.
Yeah, I think one of the things that I've seen is that the term bundling, like say you have, I don't know, the layer one's trying to process like 100 transactions per second. Well, you kind of extract some of that and say you process 90 of those transactions in a different place. Someone validates them on your behalf, and then you'll just bundle them together and submit some reference to the transactions that you've done off chain. And like I say, this has become extremely popular. We'll talk about some of the examples, but just to name drop a few, we have the Lightning Network, which is obviously a very big one, and we'll talk a little bit later about what's going on in El Salvador, because they actually base all their infrastructure off the Lightning Network, which is a bit mad. But do you want to talk about some of the examples and some of the ways that we can actually do this in a bit more detail?
Yeah, definitely. And the nice analogy for the whole picture is, as you said, like bundling and or batching. You have a similar thing in the old kind of traditional banking world. So you have what they call real-time gross settlement systems, RTGS, which is kind of for moving money in real time between banks. So when you make a payment from one bank to another, then they're using this real-time system. Or you can have what's called net settlement. So instead of doing every transaction, they'll just let all the bank accounts independently debit and credit all day. And then whatever the net is, whatever the final state is at the end of the day, they'll settle that. And layer two is much more similar to that net settlement idea. So you're just kind of recording the end state. So on that, with that example in mind, one of the first and earliest ways of doing layer two was actually what we call state channels. And this is basically what Lightning Network in Bitcoin or something like the Raiden Network in Ethereum are actually based on. So state channels are a way of taking your money, your account, for want of a better word, your wallet, and treating its state or the amount of money in it as this off-chain thing that you can go and pay. So me and Alec could set up a state channel together, and it's quite peer-to-peer actually. So him and I would say, okay, we both got £5 each, and we're going to start playing tiddlywinks for 10p, 10p a go. So, I might win a game, I'd win 10p, he might win the next game, get 10p back. So the money constantly going back and forth between us. And at the end, say I've won 100 games and he's only won 10 because he's not very good at tiddlywinks, then I would end up with that larger balance and we'd settle. So we do this net settlement piece at the end, right? So again, this is what Lightning Network is based on, and it's very similar in analogy to opening a bar tab, right? And then just paying at the end what the final state is. So how does that work in practice? So typically, again, it's peer-to-peer normally. So you have two people like me and Alec who want to start one of these channels. So we have what's called an opening of the channel. We set it up. We both lock some money in there. So basically we have our initial balance in this channel setup. Then we do our number of off-chain transactions back and forth, while we're playing tiddlywinks, and then finally we'll close that channel at the end. And basically, all that goes on chain is the start, the opening of the channel, and the ending, the final balance, and how we close the channel and release our funds again. So all the time between, our funds are effectively locked in this channel, and we're just passing it back and forth based on whatever we're doing. And there's only two events to go on chain. So that's fundamentally how the state channel model works.
Yeah, I've seen like comparisons of this to if someone's say doing, I don't know, a job for you, like they regularly submit some kind of jobs and they want to, instead of I say do a year's worth of work, I can say upfront put 100 grand into one of these channels, and every time you complete some bit of work for me, I'll give you 1 grand of that 100 grand that's on chain. But rather than me sending a grand every single month or every single week for the work you do and incurring lots of transaction fees as a result of that, if I just lock 100 grand into that, you know that there's some kind of security and I have some kind of proof of funds. So you feel that, okay, actually, I'm going to give you the money. And then off chain, I'll basically give you some transaction that you're allowed to submit at any time, which enables you to actually gain, say, the first grand. And then after 2 weeks, with the second grand, the third grand. And at any point in that state channel, you can actually submit the transaction and say, okay, well, actually, I've done enough work now. I'm going to take 50 grand of that 100 grand and job's done and we've settled and that's the channel ended. Yeah, it's quite a powerful tool, right? Especially when we kind of think about, microtransactions or multi-party stuff, like when you want to spend lots of frequent transactions. And we kind of talked in previous episodes about the idea of people wanting to break down monthly payments into daily payments, into secondly payments potentially, and these offer a really cool solution to do that.
Yeah, and as you said, that's really crucial, right? There's different things in place to protect your money, and the fact, if you have been paid so many times, then you still want to be able to get out what you should be owed at a given point in time. Because when you set up that channel, you actually are almost normally predefining a future date when you're expecting to close it. So if anything goes wrong in the interim, there is actually a way you can get out of it. And there are a few different models for doing these state channels. One of the biggest and most popular ones is hash time locked contracts, which is exactly what's used in the Lightning Network, right? Now, I said they were peer-to-peer, and that's the ideal way. And lots of the oldest ones, which go back to like 2013, 14, were peer-to-peer. In the Lightning Network, it's a bit more complex because actually you have, as the name suggests, a network of people that you try and route your funds through. So it's kind of recreates this very complex web of money flowing around. And again, we'll probably cover that all in a future episode. But the good thing about them is that if you take something like Bitcoin, the fees are very high if you want to directly pay on chain. If you move to the off chain Lightning Network, the fees are actually significantly lower because you're not demanding block space in Bitcoin, the base layer, layer one, every time you want to transact. You're just keeping a lot of it off chain in the interim.
Yeah, so that is state channels, which you said is kind of gaining popularity. Lightning Network, things like this. The other type that we have that's gaining popularity is rollups or zero knowledge rollups. There's actually a few different types of this, but like I say, we're going to cover zero knowledge proofs because zero knowledge technology generally is gaining a lot of popularity. Is very critical for Web3 going forward. So we'll do an entire episode on that. But these zero knowledge, like layer two rollups, effectively, similarly to what Jack was talking about, bundle multiple transactions off chain and they validate them using these zero knowledge proofs, right? And then submit a single proof of the entire kind of bundle of transactions back to the main blockchain. And this has a couple of other benefits as well. It maintains data privacy, reduces the load on blockchain similar to before, and significantly improves the scalability and efficiency.
Yeah, I think rollups are just generally very interesting. As you say, the core idea behind rollups broadly is batching, as we said before. But there are different flavors. So there are two broad types that are used. And again, lots of this is Ethereum based because that's where a lot of this work's going on. The first type is what's called optimistic rollups, which is funny because actually what they do is they assume your transactions are valid by default, right? So it's like, again, doing that lack of checking at the door of the bouncer and you're going into your club, they're not really checking, but you can be challenged with what's called a fraud proof later. And if you do have a valid fraud proof that says, well, that transaction, you should have checked him, he's brought in something he shouldn't have, then the person who produced that block will be slashed, this idea of losing some of their block reward. So that's the optimistic case. Now, we don't want to focus on that. As you said, we want to focus on these much cooler zero knowledge rollups because they're much more powerful and they don't assume that it's valid by default. They actually provide proof up front. They say, actually, no, this is valid, and here I can prove why. But it, as you say, uses these zero knowledge proof and zero knowledge snarks, they're called. But again, we're not going to go into that today. That's the technology it uses, and it's very sophisticated cryptography. It's a field that's moving very fast right now that can help you basically prove things about generalized computation, right? So you can
Mm.
prove that this smart contract executed in a given way, but you can prove those statements to someone and convince them without having to give them all the data, without having to have them reproduce that whole computation themselves. So zero knowledge rollups are this idea of batching a bunch of transactions together and then providing a really small compact proof that this whole batch of transactions does represent the last 1,000 transactions that happened in Ethereum.
Okay, that makes sense. I think one of the things I've read is that it's actually quite hard to generalize these computations, right, in a lot of ways. So the actual creating of the computation right now is probably as difficult as maybe the cost of actually doing them on the main chain anyway. But it seems like they're becoming more efficient and more scalable. So this could be like a really positive direction for layer 2 scalability in the future.
Yeah, definitely. If you'd asked this question like 3 years ago when I kind of first heard about them, then people were saying, well, this stuff is fine, it's clever, but it's not very efficient. And it's still true. It's not as efficient as doing some of the other techniques and, state channels and things potentially, but it's getting faster all the time.
Mm.
And that's why I think it's so exciting, because there's so many people working to improve on that base technology. And yeah, as you pointed out, really importantly, making it useful for general purpose computation is hard enough in the real world. And, it's kind of been solved more or less now. But then making it compatible with the EVM, the Ethereum virtual machine, is a
Mm.
whole other challenge, which has only kind of seen breakthroughs in the last year, 2 years maximum. So now we are starting to see what can you do when you have EVM compatible zero knowledge rollup systems. And it's really exciting. But again, the key take home point, without going into the detail, is that you can batch all this stuff up and you can prove that all these things happen off chain. So yeah, it's very impressive stuff. Not to get too far down the zero knowledge path, but the most popular rollups are still the optimistic type. So there's about 11 billion locked in the most popular optimistic rollups protocols right now, called Arbitrum. There's only around 500 million in ZK Sync, which is the most popular zero knowledge one. And it's going to be shifting over the next few years. So I think we just got to keep an eye on it.
Okay. So I think it's kind of obvious. We kind of hinted at it throughout what some of the pros and cons of layer twos are, but just to highlight those, well, the first one is increased throughput, right? We're saying that there's a scalability problem, say on Ethereum and Bitcoin and a lot of the layer ones. By bundling transactions on a layer two and then referencing them back on chain on the layer one, that means we can have more scalability, more throughput, more transactions processed per second effectively. And as we hinted at there as well, this can also reduce the gas fees. If we say processing 1,000 transactions off chain and only putting one transaction on chain, you'd hope that the transactions on the layer two are much more cost effective than they are on the underlying layer one.
Yes, exactly. And, that's the key, as we said, is like taking some of the data or computation off chain, being able to interact with the blockchain, the layer one indirectly, but at a much, much lower cost. So that's a clear benefit of using these systems, as well as the fact that you get, especially with the zero knowledge stuff that we're talking about, the privacy enhancement you get from this. Now, I say privacy enhancement because you could flip it on its head in a minute and call it a con, but by minimizing the amount of data you put on the blockchain, you're also
Mm.
minimizing the attack surface from a privacy perspective for that.
Yeah, I guess one of the things I've read there is that you're involving more parties though in the loop potentially as
Mm.
well by starting to do things on layer twos. And it's like, what's the point? And we're probably going to get to this in the end. Like, what's the point of involving a layer two? It's like an additional party and like all this kind of stuff is actually a weakness of the whole thing. So yeah, let's talk about some of the cons. We've kind of only talked about layer twos as a benefit to everything, but one of the things that we hinted at was complexity. Like, it's actually really difficult to implement some of these things, especially on the ZK rollups and ZK snarks that Jack was talking about earlier, just because due to the cryptographic complexity of trying to prove 1,000 transaction in one transaction, that's actually really difficult to do. It should be simple to verify typically, but the actual generation of the computation is quite tricky to do.
Yeah, and as it is improving all the time, but it's always going to be more variables you're adding into the system as compared with using it as a layer one. So I typically say, ideally, you would use layer one. If the costs were lower, that's what you want to do, right? Because you get much
Mm.
faster confirmation, you get better guarantee that what's happened has happened. But the complexity is, as with all these things, it is improving over time. It just happens to be starting from a very complex place to start with. The other issue I think we should mention is this data availability issue. So, but the privacy benefits of not putting everything on chain kind of rear their head as a, well, you can't necessarily prove everything about a transaction. You can't go and check everything that happened. You might have this compact proof that the net result, again, RTGS versus net settlement, you can prove what the net was, but you can't necessarily prove all the states in between. You can't go and prove that actually Alec won the first 50 games of Tiddlywinks before I won the next 1,000, that kind of thing. They'd only see what the final net result was. So that's not ideal, right?
Yeah. And I think one of the last things that we probably is a con on this stuff is around the interoperability between like different layer twos. You talked about layer noughts, chains providing interoperability underneath the layer ones. And it's kind of, well, we're getting more and more isolation potentially by having, layer twos that are just based on layer ones and kind of fixing that. And maybe it's also linked to the fact that we have more intermediaries involved in the loop with their own kind of set private custodials or whatever you want to call them that kind of separate this stuff off. I guess, yeah, the big question here is, does this actually solve the trilemma cost? Are layer twos actually solving the problem right now?
Yeah, this is a big kind of bugbear for me. Well, I actually have an issue with the premise to begin with, but I'm gonna maybe park that for a minute about whether the trilemma even exists to start
Hmm.
with. But let's assume it does. Then yeah, have we actually solved that with layer twos? Because as you said, you are introducing these additional third parties. For me, that is essentially sacrificing some element of trust. You are
Hmm.
typically giving up some trust, and we haven't given the details of how the ZK snarks work yet. But part of that, depending on which implementation, it's not just magic, right? The maths behind it can seem like magic, but there is some kind of level of sacrifice happening. You don't just get the benefits of it for free. So to my mind, it is strictly less secure. And I'm
Yeah.
willing to kind of go out and say that it's strictly less secure than if you were using it again directly natively on layer one. So yeah, you're getting more scalability, but at some extra cost. And it's not even easy to quantify that cost, right? And does it matter? That's a whole other question. But I think it's important to know that there is something you lose by going to layer two.
Yeah, I've seen like articles and there's like a lot of the news in the past around these layer twos being security problems and like
Mm.
hacks and breaches happening at the layer twos because they're typically fairly unbattle tested compared to the layer ones that they're built up on. And it's just like you say, a complete single point of failure there if you're sending all your transactions off this unknown party effectively and not knowing how secure they actually are. So yeah, it's a big question. Do they solve the trilemma problem or do they just solve one part of the trilemma problem? So some interesting facts around this area. One we mentioned earlier is that the Lightning Network was adopted by El Salvador. Like obviously they want to use it as legal tender. They realized that Bitcoin was the angle they wanted to go for, but for day-to-day transactions, they knew they didn't have the throughput. So they're actually using right now the Lightning Network as a scalable solution to actually transact with, which is quite an interesting one.
I think early days, this initially was a huge boon, right? People were saying this is incredible. When this was first announced at one of the big Bitcoin conferences, everyone saying this is a huge step forward. El Salvador making Bitcoin legal tender and saying we're going to go kind of full in on this idea. And then there came a year of maybe memes against El Salvador because there were teething problems. Not everyone wanted it. There were, I think, some demonstrations in the public against it. But now, if you ask people their actual day-to-day experience, people say you can very much use Bitcoin at the Lightning Network daily for all your kind of daily needs. So yeah, they've done something that no other nation on earth has really done, which is quite exciting and shows that there is something there to using a layer two scaling, I think.
Yeah, I mean, it definitely helps that Bitcoin's currently very up, and I think their investment in El Salvador has actually come through.
Yeah.
If you'd have asked them like 2 months ago, maybe they wouldn't have been as popular. But yeah, it is an interesting one. And kind of on that point as well, it's another big thing is that it's interesting that Ethereum's roadmap actually kind of states that there is going to be this transition and a heavy emphasis on layer two scaling solutions. Vitalik was one of the big proponents of this trilemma problem, and it seems like Ethereum generally has kind of accepted it as a flaw in the system, and they have to be reliant on layer twos to kind of take the scalability forward and ensure that Ethereum can be deployed and high transactions around the world, which is, I think, it's a bit sad, really. They're kind of given up a little bit on improving Ethereum to the point at which it can do everything, right?
Yeah, and I think it comes back to the fact that people hold this idea of decentralization or this perception that having many nodes validating is decentralization, whether or not you agree with
Mm.
that. That idea is so powerful in the minds of many of the people influential in crypto and many of the users that they are simply, that's the mountain they're willing to die on. So yeah, I see that this trend of moving to layer two kind of broadly across the industry is only going to continue. And speaking of trends, one of the other interesting things is we've seen some of these newer networks, like your polygons, for example, which kind of I've seen it described as a layer zero and a layer two, which doesn't help for this episode. But think of it
No.
as it's
Mhm.
still it's aiming to help scale Ethereum at its core, and that has been adopted very widely for all sorts of different things, right? It's been used by major platforms like Starbucks, Reddit, Nike. I'm pretty sure at one point there was also an integration with Instagram for NFTs for
Mm.
Polygon. So, it's made really big inroads. And all of this has been on layer two infrastructure because lots of the big brands and lots of big companies who want to dip their toes into Web3, they one of the immediate problems they have is the lack of scalability, the high cost of doing so. So naturally, they have chosen to use these layer two solutions as the first way to kind of test the waters of what they want to do.
Yeah, I think they used to be called Matic or something like that, right? When
Yeah.
they were just a scaling solution for Ethereum, and now they're kind of, I think their angles like multi-chain system, and they're going
Mhm.
towards this
Yeah.
more interoperability layer, which is, I mean, it's worked quite well. I mean, Polygon's like always in the news these days, right? I think Mark Cuban invested in them as well, which is a major adoption, like on every exchange, obviously. I think they're pushing quite heavily into the gaming sector, which is always a big one for this kind of stuff. And I think, yeah, we're kind of coming to the closing section of this episode. It's like, what's the future look like for this space? And I think one of the big things when it comes to adoption is cost, right? It's how much does it cost to use these things and can it keep up with my daily transactions? And I think most people will see a layer two as a way to do that. They'll look at, okay, what are the transactions per second and how much does it cost me to use it? And immediately they'll be like, well, this is cheaper and faster. That's better. I'm going to use it. And I think as soon as you say, we've got the security of Ethereum, but we're cheaper and faster, unless someone's doing their due diligence and looking into actually, okay, how are you achieving the same level of security as Ethereum? You're probably not, for example. I think that it's going to help with adoption, but there might be some security problems that probably come from these.
Yeah, I agree. And if you're thinking about the future, one of the trends I would actually see is this revival around layer one scaling, right? Because you've
Mm,
had something like Solana come along, which is basically trying to be a layer one scalable version of Ethereum that is actually not just saying let's shift it all to layer two. They are trying to do as much as possible on layer one. You've also had other recent entrants like Aptos and Sui with some really
mm,
smart people behind them trying to solve things from layer one. And I think one thing we haven't really mentioned is that layer one scaling and layer two scaling are not mutually exclusive. You can do both, right? So
mm,
I would like to see more work being done in both areas. I think all the developments with ZK rollups are great and they will be very useful for all blockchains in the future potentially because they are typically, can be quite agnostic to different chains too. But the layer one developments are almost as important, if not more important. So to get this used by everyone and to have all our internet activity mediated by a blockchain, I
mm.
think we're almost certainly going to have cracked it in both of the two domains for sure.
Yeah, I saw someone say something along the lines of if you need layer two, then your layer one's not right. And I think with the big chains like Bitcoin and Ethereum, maybe it is tricky to get those substantial upgrades done. Like you've seen how long it took for the Ethereum 2.0 to come, but like a chain like Solana, smaller community, they're a bit less risk averse. Maybe they can actually achieve what everyone's trying to achieve on the layer two at the layer one. But it probably is tricky with the momentum that Ethereum, Bitcoin have, the people on there right now to all of a sudden overnight change the entire protocol to be like, hey, this is how we get more scalable. But yeah, layer ones ideally, but there's always probably going to be a place for layer twos, I guess, in the future.
Yeah, well, I think that's a decent place to wrap this one up. I think it's a good self-contained topic, layer zero, layer one, layer two. We didn't go into so much detail on layer zeros because, again, I think that it's such a complex and abstract thing. We probably want to talk about that in a separate episode. Similar with the zero knowledge tech, that's going to require much deeper commentary on right to explain exactly what they are. But the most important thing to take away is that we have effectively these three layers, these core components of most Web3 systems now. And it's good to know, where it sits and whether you're whether you're using a layer one or a layer two. That's the big question. So, yeah, I think with that, we'll say to our audience, thank you for listening wherever you may be, and join us next time to untangle a little more of Web3.
Thanks for tuning in to another episode of Untangling Web3, produced by Emma Camilleri.
Don't forget to send us your thoughts, questions, and comments on social media, and be sure to follow us on your favorite podcast provider to catch the next episode. See you next time to untangle a little bit more of Web3.
The views we express here are our own and do not reflect the views of our employers.